Hello students, welcome to this session here at Infinity Learn by Sri Chaitanya. I'm Aniruddha Sir, your physics faculty, and today we are doing the paper solution for the 27th January shift 1 for your JEE 2024 the January attempt. So let's get started with those questions. First one is given, position of an ant, S is in meters, moves in the YZ plane given by S is equal to 2t square j cap plus 5k cap. The magnitude and direction of the velocity at t equal to 1 second is how much? So this is a displacement equation. We need to find the velocity. So we just differentiate this. Velocity vector is ds dt vector. If you differentiate this, 2t square is going to give you a 4t j cap plus this is a constant. So you'll have plus 0k cap. So that is just equal to 4t j cap. At t equal to 1 seconds, you can put t equal to 1, you get 4 j cap as the answer. So it is 4 meters in the y direction. That is the answer for it. Let's go for the next question. This says, given below are two statements, viscosity of gases is greater than that of liquids. Now this is obviously an incorrect statement because we know liquids have higher viscosity than gases. You can even think about it from a practical scenario. Next says, surface tension of a liquid decreases due to the presence of insoluble impurities. This is a correct statement because insoluble impurities decrease surface tension and soluble impurities increase the surface tension. So over here, statement 1 is incorrect but statement 2 is correct. Option B is the correct answer here. Next question says, if the refractive index of a material is cot A by 2, where A is the angle of the prism, then the angle of minimum deviation is going to be what? So this is given as the refractive index. We know for a prism, the refractive index is sine of A plus delta m divided by 2 divided by sine of A by 2. Now this refractive index is given as cot A by 2. So we directly replace it and write the cot as cos A by 2 divided by sine of A by 2. Putting n is equal to cot A by 2 and cot is just cos by sine. And that is equal to sine of A plus delta m by 2 divided by sine of A by 2. Cancel the sine A by 2's from both sides. So you have cos A by 2 is equal to sine of A plus delta m by 2. I can write it sine of pi by 2 minus A by 2. And that is equal to sine of A plus delta m divided by 2, which just tells you that pi by 2 minus A by 2 is equal to A plus delta m by 2. So this, if I take 2 common over here, then I can write pi minus A divided by 2 is equal to A plus delta m by 2. Cancel the by 2's out. So you have pi minus A is equal to A plus delta m. So we get delta m is equal to pi minus 2A. That is the answer over here. Let's head to our next question. It says a proton moving with a constant velocity passes through a region of space without any change in its velocity. If electric field and magnetic field are represented here, then the region of space may have which one? Which is the most appropriate answer? Which is the most appropriate? So in all of these cases, it says there is no change in velocity. In which case will you have no change in velocity? Firstly, E equal to 0, B equal to 0. That is fine. There's neither an electric force nor a magnetic force. So this is obviously applicable. No force acting, velocity does not change. Next case is E is equal to 0, B is not equal to 0. Here also there is a possibility, there might be a magnetic force, but there is a possibility that there is no magnetic force. This would happen if the magnetic field is in this direction and even the particle is moving in the same direction or maybe opposite to it. So it's in line with the magnetic field. Then even though there's a magnetic field, there would be no force, no electric force. So obviously there's going to be no change in velocity. So this is also possible. Next is electric field is not 0 but magnetic field is 0. This is the one that cannot be possible. Because if there is an electric force, then if the electric field is not 0, then there is an electric force. It's always going to act irrespective of which direction the particle is going. So obviously if there's a force, there is going to be a change in velocity over there. So this cannot give you a case of constant velocity. In that case, you would even think that this will also not be applicable. But this E not equal to 0, B not equal to 0, over here also you might have zero net force. How? This would be the case of the velocity selector. In this case, with both electric field and magnetic field, if the velocity happens to be E by B, then you will have no net force acting. This is the concept of a velocity selector. So even in option D, you could have the particle moving at a constant velocity. So your correct option is A, B and D. So it is option C here. A, B and D only. Next question says acceleration due to gravity on the surface of the earth is g. If diameter of the earth reduces to half of its original value, mass remains constant, then acceleration due to gravity on the surface of the earth would be what? Just by reducing the diameter. So if diameter is made half, radius is also made half. We know acceleration due to gravity, g is equal to gm by r square. If g is g by r square, you know g is inversely proportional to 1 by r square. So if the radius is reduced to half, reduced to half, you can right away see that g dash is going to be 1 by proportional to 1 by r by 2 whole square. So this 2 square goes up on top. So your answer comes out to be 4g, because this 2 would go up top. 2 square would go up top as a 4. Next question, it says a train is moving with a speed of 12 meters per second on rails which are 1.5 meter apart. To negotiate a curve of 400 meters, height by which the outer rail should be raised with respect to the inner rail is how much? So this is a case of banking of roads. Even though it's given as rail, it's a case of banking of roads. Because the road, if it's making a turn like this, of whatever radius, the road has to be banked at an angle. If this angle is theta, then we know for banking of road formula, tan theta is equal to v square by rg. V is the velocity, r is the radius of the turn, g is the acceleration due to gravity. Now in this banking setup, the width is 1.5 meter apart. So you know this is 1.5 meter. And let's assume this is h. This h is what we need to find out. This h is what we need to find out. How much should that side be raised by? And you can see from this right angle triangle, tan theta is equal to h by 1.5. So that's what we replace in here, and I can write the equation as h by 1.5 is equal to v square by rg. V square is 12 square, 12 into 12, by rg, r is 400 into g is 10 into 10. So I believe put it as 10 to the power 3 here. This 4 takes out a 3 here. So h comes out to be 3 into 1.5 into 12 into 10 to the power minus 3. Into 10 to the power minus 3. We leave it at that. That makes it 1.5 into 12 will go with 18. So it is 3 into 18, 10 to the power minus 3. 3 into 18 is 54, 10 to the power minus 3. So our answer here is 5.4 centimeter. That is the height it is raised on the other end. Next question says, which of the following circuits is reverse biased? Reverse biasing generally means that the P side is connected to a lower voltage terminal and the N side is connected to a higher voltage terminal, right? So over here we see that the P side is connected to a higher voltage. This is 0 volt. P side connected to higher voltage. So this is forward biased. Over here also you see the P side is connected to a higher voltage as compared to this. So it is also forward biased. Here P side is connected to 0 volt, but you see the negative side is connected to an even lower value. So technically P side is connected to the higher voltage. So this is also forward biased. But in this case you see the P side is connected to the lower voltage. N side is connected to the higher voltage. So this is the case where you will have the reverse bias. because P side is connected to the lower voltage. Let's move to the next question. It says identify the physical quantity that cannot be measured with a spherometer. Now this stumped plenty of students because the spherometer is not technically in your syllabus. How do you answer this? You answer this by looking at the options over here. You see that option A, radius of curvature, option C, thickness of a thin plate, and option D, radius of curvature. These three measure length. These three would all be measurements of length. Measurements of length. And the only odd one out here is this one, specific rotation of liquids. So just from that logic, you can answer that this will be the correct one. This is the one that cannot be measured. Because if it can measure length, it would have been able to measure in some extent to all of them over there. Next question. Two bodies mass 4 gram and 25 gram are moving with equal kinetic energies. The ratio of magnitude of their linear momentum is how much? So kinetic energy is same. We know P is equal to, momentum is equal to root over of 2 mk, which means the momentum is proportional to root over of their mass. So if the masses are in the ratio of 4:25, root over of that will give you 2:5, because root of 4 is 2, root of 25 is 5. So you have the answer directly over there. Next question says 0.08 kg air is heated at a constant volume through 5 degrees Celsius. Specific heat of the air at constant volume is 0.17 kilocalorie per kg per degree Celsius. And 1 joule is this. What is the change in internal energy in terms of joule? So internal energy, delta U, is mCV into delta T. That is always the change in internal energy. Mass is provided to us. It's just putting the values in. CV, specific heat capacity at constant volume, 0.17 kilocalories. So 0.17 into 10 to the power 3. Into, this is given in calorie. You wanted to final answers in joule. So you also multiply the conversion. That is 4.18. And the change in temperature is 5 degrees Celsius. Change in temperature is 5 degrees Celsius. So I'm not going through the entire calculation here. If you calculate, you will eventually arrive at 284 joules. You can approximate a few calculations. For instance, you can make it 4.2. You can make 4.2, or you can make 5 into 8. That would make it 0.4. 0.4 into 4.18 would be roughly around 16 or 17. And 17 into 17, 17 square would roughly go to your around 289. So you have around that, this one, this is your correct answer. It would be a little less, you'd have it as a correct answer. Next question. Radius of the third stationary orbit of electron for Bohr's radius is r. Radius of the fourth stationary orbit is going to be what? So we know radius of orbit is proportional to n square by z, n being the orbit number, z being the atomic number over there. So simply from that, we can tell that r1 by r2 to n1 square by n2 square. r1, the radius is capital R, divided by r2 is capital R was for the third stationary orbit. So 3 square by, you want it in the fourth stationary orbit, by 4 square. So r2 comes out to be 4 square, that is 16r by 9. You have your answer right away, option B. Next question says that a rectangular loop of length 2.5 meter and width 2 meter is placed at 60 degree to the magnetic field. The loop is removed from the field in 10 seconds. The average EMF induced in the loop during this time is how much? Now over here, the flux associated in the very beginning with this loop and magnetic field, phi is equal to BA cos theta. BA cos theta. Magnetic field B was 4. Rectangular loop of dimensions 2.5 and 2 meters. So the area was 2.5 into 2. Into theta was given as 60 degree. Theta was provided 60 degree. So cos of 60. That made it, this was equal to 2.5 into 2 is 5, 5 into 4 is 20, 20 into cos 60 is half. So you'll eventually arrive at 10. you'll eventually arrive at 10 Webers. That is the flux associated with this loop. Now when you take it out, the EMF E is equal to minus d phi dt. In this minus d phi dt, you can understand when you take it out, the entire flux is removed, because at the end the associated flux is 0 and the time it takes is 10 seconds. So I can even write it as minus of delta phi by delta t. So minus of delta phi means what is the final flux? Final flux is 0 minus of the initial flux was 10 divided by the time is 10. So minus of minus 10, that makes it 10 by 10. So it is 1. So it is just plus 1 volt. Be very mindful if you don't consider this minus sign here, or if you do it 10 minus 0, you would arrive at the incorrect answer of minus 1 volt. So keep that in mind. Next question. Electric charge 10 microcoulomb placed at the origin of XY coordinate system. 2 points P and Q situated at root 3, root 3 and root 6 meter respectively. What is the potential difference between the points P and Q? So if you have the coordinate axis like this is where you have placed the charge, whatever the charge is, 10 microcoulomb. One point is root 6, 0, so somewhere around here, and the distance is root 6. And the other point you have at root 3, root 3, so maybe somewhere around here. Coordinate of that is root 3, root 3. What is this distance? That distance d would be equal to root over of root 3 square plus root 3 square, which is just root 6. So as you can see, this point and this point are technically the same distance away from the point charge. You don't even need to solve after that. It directly tells you, because the formula for potential is kq by r. Charge is same for both the points, like charge that is causing the potential is same. And if r is also the same, that means the potential at both P and Q will be the same. That tells you that the potential difference between them is going to be 0 volts. P and Q will have the same potential. Next one says a convex lens, focal length 40 centimeter, forms an image of an extended source of light on a photoelectric cell. A current I is produced. The lens is replaced by another convex lens having the same diameter but focal length is 20 centimeter. The photoelectric current now is going to be what? So putting a lens and converging that light has no role, because at the end the amount of energy that hits it per unit time is still the same. The number of photons that hit it is still the same. So photocurrent is not going to change. It is going to be D. It's going to remain whatever it was in the beginning, because still the energy coming in is still the same. Number of photons coming in is still the same. Next one says a body of mass 1000 kg is moving horizontally with a velocity of 6 meters per second. If 200 kg extra mass is added, the final velocity is going to be what? This is pure conservation of momentum for a perfectly inelastic collision. What is the initial momentum? Initial momentum is this mass moving with this velocity. So 1000 into 6. Initial mass, initial velocity. That is equal to, now you have added 200 on top of it. So in the final case, the mass is 1200 and the velocity is v. The velocity it picks up is v. So right away from that you can get this is 5, go with 6, take it out. Your velocity comes out to be 5 meters per second. So it is option D. Okay. Next one says a plane electromagnetic wave propagating in the x direction is described by E is equal to 200 volt per meter sine of 1.5 10 to the power 70 minus 0.05x. They are asking for the intensity of the wave. Since we know the electric field and this is the peak value of the electric field, we can directly put the formula for intensity. I is equal to half epsilon naught E naught square into C. So we have half into epsilon naught is 8.85 10 to the power minus 12 into E naught square, that is 200 square, into the speed of light 3 into 10 to the power 8, right? So what do we get over here? We get this will keep one of the two hundreds and put the other one as 100 here. Put the other one is 100 over there. So we get this is 10 to the power 10. That goes here and leaves behind just a 10 to the power minus 2. And we have that 10 to the power minus 2 would cancel with this 200 0. So we have 8.85 into 2 into 3. If I assume it roughly 9, 9 into 2 is 18. 18 into 3 is 54. So the only possible option here, close to 54, is 53.1. That is the answer. Next question says, it's a question of units and dimensions. It says, Planck's constant and angular momentum have the same dimensions. How do we test it? Look at the Bohr's quantization condition. The Bohr's quantization condition tells you that the angular momentum is equal to nh by 2 pi. In this relation, n is dimensionless because it's a number, 2 pi is dimensionless. So that tells you that the dimensions of L should be equal to the dimensions of H. So this is a correct statement. Statement 2 says linear momentum and moment of force have the same inertias. Moment of force means torque. What is linear momentum? Linear momentum has it's m into v. M into v. This is the linear momentum, which can be written as ml by t. Whereas when we talk about moment of force is tau. Moment of force is tau. That is equal to Newton meter. If you think about it in terms of Newton meter, that would be ml2 t minus 2. That is the dimensions of torque. So they are not equal. They don't have the same dimensions. So 1 is true, but statement 2 is false. It is option A. Next question says a wire of length 10 centimeter, radius root 7 10 to the power minus 4 connected across the right gap of a meter bridge. When a resistance of 4.5 ohm is connected to the left gap by using a resistance box, then the balance length is found to be at 60 centimeter from the left end. Resistivity of the wire is this, then what is the value of R? So pretty straightforward. This is your meter bridge. On the left side you have put 4.5 ohms. 4.5 ohms. You have brought the connector here for your meter bridge. Over here you have put the unknown resistance. Let's call it R0. Let's call it R0. And this length is 60 centimeter. Which means this length would be 40 centimeter. It's a meter bridge. So we know 4.5 by R0 is equal to 60 by 40. That is 3 by 2. That's roughly 1.5. They will cancel out with this to give you a 3. So R0 comes out to be 3 ohm. The resistance of this is 3 ohm. Now that resistance, we know R or R0 should be equal to rho L by A. So rho is equal to RA by L. R we had got as 3 ohms. A's radius is given as root 7. R is 3 into area would be pi R square. R square is 7 into 10 to the power minus 8. Minus 8 divided by the length. The length is given as 10 centimeter, which is 0.1. 0.1. So we have that over here. You send that up, then this goes 10 to the power minus 7. So we have rho is equal to 21 pi into 10 to the power minus 7. So R is equal to 21 pi. So 21 pi would go to 66 because 21 into 3 is 63. Obviously, it is not 3, it is 3.14, a bit more than that. So only possible option is 66. That is the one it's going to go to. Next question says a wire of resistance R length L is cut into 5 equal parts. If these parts are joined parallelly, then what is the resultant resistance going to be? So since the length L is cut into 5 parts, resistance of each piece is going to be r by 5. It's equally cut, so it's exactly 1/5. It becomes r by 5. Once you have r by 5, now you want what is the resultant resistance when you connect them in parallel. So 1 by r equivalent is technically 1 by r dash plus 1 by r dash, so on and so forth. Or I can write it as 5 by r dash, because 5 pieces, one each added parallelly. So if I put that equal to r dash by 5, r dash is the resistance of each piece. R dash itself is equal to r by 5. So that makes it as 1 by 25 times of r, the original resistance. Next question says the average kinetic energy of a monoatomic gas is 0.414 electron volts at a temperature of at what temperature do you have that as the average kinetic energy? It's a monoatomic gas, so you know that kinetic energy value is 3 by 2 kT. It is 3 by 2 kT. So 0.414 into 1.6 into 10 to the power minus 19 is equal to 3 by 2 into k is 1.38, 10 to the power minus 23 into the temperature. That T is what we need. T is what we need. Now this will go with this with 0.3. This will go with this as 10. And I think over here we have then 10 to the power minus 22. 10 to the power minus 22 cross multiplied. So 1.6 into 2 into 10 to the power 3 is equal to T, because 10 to the power minus 22 comes here with 10 to the power minus 19. So the difference is 3, so you'll have 10 to the power 3. So that makes it 3.2 into 10 to the power 3, that is 32 Kelvin, 100 Kelvin. That is the answer. Next one says a particle starts from origin at t equal to 0 with a velocity of 5 I cap meters per second, moves in the xy plane under the action of a force which produces a constant acceleration of 3 I cap plus 2 j cap meters per second square. If the x coordinate of the particle at that instance is 84 meters, then the speed of the particle at that time is root alpha meters per second. What is the value of that alpha? So the initial horizontal speed is 5. Initial vertical speed is 0. The acceleration in the horizontal direction is 3 meters per second square. Acceleration in the vertical direction is 2 meters per second square. So first and foremost, we will find that the velocity in the x direction, when it has traveled 84 meter, Vx square is equal to ux square plus 2ax into the x, how much it has moved in the x direction. So we get Vx square is equal to ux square, that is 5 square, so 25, plus 2 into x-axis acceleration is 3, into the displacement it has in that x direction, in the x coordinate is 84 meters. So into 84, that is 25 plus this is 6 into 84, 6 into 84, or we can do it 3 into this would be 240, 240, 252, 252 into 252 into this would be 504, if I am not wrong. 504, so that is 529. Okay, we leave it at that. Vx square, because at the end we will need to find the resultant, so we'll use it as Vx square only. Let's look at Vy. Vy starts at 0 speed, but for how long time? This is only the x component direction. Okay, we can even solve it over here. Vx square is this, so that takes it to Vx is root of 529. Root of 529 is equal to 23. That is equal to 23 meters per second. Right? Now we'll find how long has it been traveling. To do that, we have Vx and we have Ux and we also have Ax. So T, the time it travels through, is Vx minus Ux divided by Ax. So Vx is 23 minus Ux is 5. divided by the area, the acceleration in the x-axis is 3, that is 18 by 3, that is 6 seconds. So it has been traveling for 6 seconds. What is the velocity it picks up in the y direction in that time? Vy, it had initial 0 velocity in the y direction. So Vy is just going to be Ay into t. That is 2 into 6, Ay was 2, that is 12 meters per second. So the final alpha that we are looking for, the final resultant velocity, V is equal to root over of Vx square plus Vy square. Vx square we already had there as 529 plus Vy square is 12 square, that is 144. How much does that come out to be? This is 660, 673. Over of 673. So your answer here, alpha, is 673. That is the answer for this question. Next one we go for, says a thin metallic wire having a cross-sectional area of 10 to the power minus 4 meters square is used to make a ring of radius 30 centimeter. A positive charge of 2 pi coulomb is uniformly distributed over the ring, while another positive charge of 30 picocoulomb is kept at the center of the ring. Tension in the ring is N, provided that the ring does not get deformed. What is the tension? They are looking for the tension over there. To solve this question, we think of a very small portion of the ring. A very small portion of the ring, and over here, the angle that it traces out at the center is, let's say it is theta. Angle is theta. We split it down the middle so that each side is theta by 2. Now the tension over here pulls in these directions. Pulls in these directions. And this angle here would be that theta by 2. So the force that pulls this piece downwards, that is T sine of theta by 2 on this side, and also T sine of theta by 2 on this side, because this angle will also be theta by 2. So the net downward force, the force that's pulling it inwards, is 2t sine theta by 2. And that is equal to the force that this piece experiences because of the charge placed over here. This experiences an outward electrostatic force. How much would that be? That would be kq square, kq into dq, or rather q naught into dq divided by r square. Now what is q naught? Q naught is the charge over here, and dq would refer to the charge in just that piece. In just that piece, what is the charge it has? Now how much charge will that have? dq would be equal to lambda dl, where lambda would be the charge per unit length and dl would be this length. dl would be that length. And that arc length is related to the angle theta and the radius r by lambda into dl would be r d theta. R d theta, or not d theta, you can just write it in terms of theta only. R into theta, right? That's the arc length. So now we have everything that we need. Since theta we choose is very small, we only take for a very small angle of theta. That is why we can assume sine theta by 2 is theta by 2. So we'll have 2t into theta by 2 is equal to k q into that dq is equal to lambda r into theta. Cancel the thetas out, cancel the 2's out. T is equal to kq lambda r. What is k? K is 9 into 10 to the power 9. So this is q naught. Q naught is given as 30 picocoulomb. 30 into, so this is 10 to the 9. 30 into 10 to the power minus 12. Lambda is the charge per unit length. So the charge is 2 pi coulombs. So 2 pi charge per unit length. What is the total length? The total length is 2 pi r, the radius being 30 centimeter. Okay, there's also an r square. My bad, I missed out on an r square over here. There's a 2 pi into r. R is 30 centimeters. So 0.3 into, we had an extra r up top, 0.3 divided by the r square, which is 0.3 square. Cancel out the 2 pi's first of all. Cancel out one of the 0.3's. 0.3 square can be written as 9 into 10 to the power minus 2. Cancel the 9's out. Send this up top, 10 to the power 11. So we have 30 into 10 to the power 11 into this, 10 to the power minus 1, because 10 to the power 9 plus 10 to the power 2 would be 10 to the power 11 into 10 to the power minus 12, 10 to the power minus 1. So we get the final tension, T is equal to 3. So the answer is the tension is equal to 3 Newton. That is the final answer. Let's opt for the next one now. It says two coils have mutual inductance of 0.002 Henry. The current changes in the first coil according to the relation I is equal to I naught sine of omega t, where I naught is 5 amperes, omega is 50 pi radians per second. Maximum value of EMF in the second coil is pi by alpha volts. What is the value of that alpha? So we know EMF is equal to M di dt. There's a negative sign, you can even treat it minus, but we are just looking at the magnitude, so we don't worry about that. So over here, mutual inductance is given as 0.002 into, if I differentiate this current equation, I will get I naught omega cos of omega t. We want what is the maximum value of EMF. For maximum value of EMF, this cos value will have a maximum value of 1. So the maximum EMF is just going to be this M I naught into omega. M was what? 0.002. I naught was 5 amperes into omega is 50 pi. It is 50 pi. Okay. Remove it, put a 10 to the power, put a divided by 1000 over here. Divided by 1000 over here. 2 into 50 is 100. That removes this. So 5 by 10 will remove with the 2. So you have E max is equal to pi by 2. So this alpha is equal to 2. That is the answer. Next question says two immiscible liquids of refractive index 8 by 5 and 3 by 2 respectively put in a beaker as shown. The height of each column is 6 cm. The real depth of each liquid is 6 cm. A coin is placed at the bottom of the beaker. For near normal vision, the apparent depth of the coin is alpha by 4. What is that apparent depth? So direct formula, the apparent depth for this liquid plus the apparent depth for this liquid. That's it, because it's at the extreme bottom. So both will have the whole thing. So the apparent depth, the real apparent depth is the real depth in liquid 1 divided by the refractive index of liquid 1 plus the real depth in liquid 2 divided by the refractive index of liquid 2. So what do we get? For both of them it's 6 cm. 6 divided by, in fluid 1 it is 8 by 5. Plus in fluid 2 also it is 6 cm. Refractive index is 3 by 2. It's 2 here. This leaves behind a 3 and a 4 here. So 15 by 4 plus a 2. So that makes it 4 into 2 is 8. 8 plus 15. That is 23 by 4. 23 by 4. So alpha is equal to 23. That is the answer. Direct formula. Next question says a nuclear fission process, high mass nuclide alpha 236, A236 with binding energy 7.6 mega electron volt per nucleon dissociates into middle mass nucleates. Middle mass means it equally splits, having having the mass number 118 of each of the pieces, the binding energy of them is 8.6 mega electron volt per nucleon. The energy released in the process would be how much? So it is pretty simple. Over here, let's call it element X, and it breaks into this element Y. Breaks into this element Y. So that just means X is breaking up into 2Y, going into 2Y. So the mass, the binding energy is just equal to the binding energy of Y, total binding energy of Y, 2 times of that because 2 Y's are formed, minus the total binding energy of X. When I say total binding energies, doesn't mean 8.6. It does not mean 8.6. This is per nucleon. So this is 2 into 8.6 per nucleon. How many nucleons are there? 118. 2 into 8.6 into 118 minus Bx is 7.6 per nucleon. Total nucleons are 236. So 7.6 into 236. 2 into 118 is also 236. Take 236 common. Then you'll have 8.6 minus 7.6 mega electron volt, that is equal to 1. So final is 236. So the answer is going to be 236 mega electron volts. This one says 4 particles each of mass 1 kg placed at the 4 corners of a square of side 2 meters. Moment of inertia of the system about an axis perpendicular to its plane and passing through one of its vertex is how much kg per meter square? So simple question, the axis passes through this side, through this end. So this, if the side is 2 meter, there is a mass at a distance of 2 meters, another mass at a distance of 2 meters, and the last one is at a distance of 2 root 2 meters because it's a diagonal. So the total moment of inertia is equal to m1 into 2 square, mr square for this one, same mr square for this one, plus this 1 kg is at a distance of 2 root 2, so 1 into 2 root 2 whole square. So we get 4 plus this is 8. It comes out to be 16. So the answer is 16. That is the answer for this. Next one says a particle executes simple harmonic motion with an amplitude of 4 cm. At the mean position, velocity of the particle is 10 cm per second. Distance of the particle from the mean position when its speed becomes 5 cm per second is root alpha. We need again that value of alpha. So how do we solve this? The amplitude is 4 cm. Maximum velocity is 10 cm per second. Now we know A omega is equal to V max. So from there omega is equal to Vm by A. Maximum velocity is 10 divided by the amplitude is 4. So we get 2.5 radians per second. That is our omega. We have that omega. Next, distance of the particle from the mean position when speed becomes 5 centimeters per second. So V is equal to omega root over A square minus X square. V is given as 5 centimeters per second. Omega was 2.5, we calculated. This A was, amplitude was 4 centimeter. So that is 4 square, that is 16 minus X square. Cancel it out, goes with the 2. So if we square both sides, 4 is equal to 16 minus X square, or X square is equal to 12. So X is root over of 12. So alpha is equal to 12 over here. That is the answer. Next question goes for 2 long straight wires carry equal currents in opposite directions as shown. The separation between the wires is 5 cm. Magnitude of the magnetic field at a point P midway between the wires is how much? So if they carry currents in the opposite direction, you can see both of their magnetic fields will point into the pitch. So their magnetic fields technically add up. So your net magnetic field is equal to 2 times of the magnetic field from any of the wires. So we do that. 2 into mu naught I divided by 2 pi d, where d would be this distance. Since the distance between the wires is 5 centimeter, that d would be 2.5 centimeter. So we have 2 into 4 pi into 10 to the power minus 7. Current flowing is 10 amperes divided by 2 pi into 2.5 centimeters, right? So 2.5 into 10 power minus 2, I'm putting 100 up top. Let's keep 100 up top. So remove it, goes with the 2. The 2.5 can be taken out with this to leave behind a 4. So 2 into 2, 4 into 4, that is 16 into 10 to the power minus 5. 16 into 10 to the power minus 5. So that is 1.6. Just a moment, students. Did I miss out on any value over there? V naught I by 2 pi d, that goes with the 4. That's gone with the 2. 2 into this comes out to be 16. Okay, 160, my bad. Yes. 160 10 to the power minus 6. So this in micro Tesla is 160. That is the answer. Next one says the charge accumulated on the capacitor connected in the following circuit is how much? You want the charge on this capacitor. For that, first and foremost, understand that in the steady state, this wire is technically cut because the capacitor won't allow any charge to flow through it. So the resistance of this line is 3 ohms and the resistance of this line is 10 ohm. Those two lines are parallel to each other, so the equivalent resistance comes out to be 3 into 10 divided by 3 plus 10, that is 30 by 30. That is the resistance. From there I can get what is the main current coming in. The main current coming in, I is equal to V divided by that equivalent resistance, that is 10 divided by 30 by 13. So we get 13 by 3. I is equal to 13 by 3 amperes. Now this is the current coming in. The current splits, goes I1 in this line and goes I2 in this line. Let's use a little bit of nodal analysis. Using that nodal analysis, let's consider this is at 10 volts and this is at 0 volts. Just using a little bit of nodal analysis. Now this I1 current flows through this also. I2 current flows through this also. What is this I1? I1 for a parallel network, current through one branch is equal to resistance of the other branch divided by sum of resistances into main current. So if I am looking for the current in this branch, that is equal to the resistance of the other branch, which was 10, divided by sum of resistances, that is 10 plus 3, 13, multiplied with the main current, which was 13 by 3. 13 by 3. So I1 comes out to be 10 by 3. 10 by 3 ampere current flows in this line, and in the other line I2 is equal to the other resistance, which is 3 ohms, divided by 10 plus 3 again 13 into the main current is still 13 by 3. Cancels. So I2 comes out to be 1 ampere. So in this line 1 ampere current flows. So what is the potential drop across this R2? V2 is equal to I1 into R2. I1 was 10 by 3 into this is 2. So it is 20 by 3. And what is the potential drop across R4? So V4 is equal to this I2 into R4. I2 we got as 1 ampere into R4 is 4 ohms. So that comes out to be 4 volts. Now since the potential drop here is 0 volt, we are considering it to be 0 volt. That means this point will have the potential of V2, that 20 by 3, and this point will have the potential of the 4 volt. Those would be the potentials. So technically the potential difference across the capacitor that VC is 4 volt minus this 20 by 3 or 20 by 3 minus the 4 volt. So VC, potential difference across C, is equal to 20 by 3 minus 4. That is 20 minus 12 by 3. That is 8 by 3. 8 by 3 volts. The capacitor itself has a capacitance of 150 microfarad. So we want the charge. Q is equal to CV. C is 150, 10 to the power minus 6 microfarad into the voltage VC was 8 by 3. C into VC. Sell it out, leaves behind a 50. 50 into 8 is 400. So 400 microcoulomb. So the answer is 400 over here. I believe this is the last question. It says if average depth of an ocean is 4000 meter and bulk modulus of water is 2 into 10 to the power 9 Newton per meter square, then fractional compression delta V by V of the water at the bottom of the ocean is how much? The value of alpha is, you just need the value of alpha, okay? The fractional change. Now we know bulk modulus formula. Bulk modulus is equal to the pressure divided by delta V by V. So delta V by V is equal to pressure divided by the bulk modulus. Where does the pressure come from? It comes from the depth below the liquid surface. So it is just going to be rho GH divided by the bulk modulus B. Putting the values in, we have density of water 1000 kg per meter cube. G is 10 and the height is 4000 meter. So 4000 divided by the bulk modulus. The bulk modulus is given as 2 into 10 to the power 9. 2 into 10 to the power 9. We have to represent it as in terms of 10 to the power 2. So no issues over here. Goes with the 2000. So over here we have 3, 7, 10 to the power 7, 10 to the power minus 9. So we get 2 into 10 to the power minus 2. Which means our answer here, alpha is equal to 2. That is the answer. So I believe that was the last question. That finishes our paper solution for the 27th Jan shift 1 of your JEE Mains January 2024 paper. You will also be having the other paper solutions as well. Do check them out. That's it from this session. Thank you all so much for tuning in. Catch you all again in the next one.